So we're going to go three-dimensional now. So we're going to take those representative rectangles we had and start spinning them all over the place. And that's going to cause some funness. First thing today, disk method, which means absolutely nothing to you. So we're going to find the volume of a solid of revolution, meaning we take a region, if you will, spin it around a line, and it generates a three-dimensional figure. And our job is going to be to find the volume of that figure, because who doesn't want to do that? Later on, we'll talk about something called the washer method, but you're not ready for that yet. And then today you should give at least 2 hugs. You gonna take a hug from the big boy?
One boy, one girl.
Huh?
One boy.
It's up to you. I don't care. No judgment. You hug whoever you want. I mean, I would clear with them first. Don't stop a stranger in the hallway.
I don't know that. Make a funny story. It makes a lot of fun.
Sure.
Just walking on top. Sounds good.
Okay, here we go. So we're going to start with this representative rectangle that we talked about, and I blew that rectangle up so you can see it. Now we actually have a measurable width. We talked about before when we were doing the representative rectangles that it didn't have a measurable width. It was really skinny. We shrink it down. We'll get to that eventually. But if I take that rectangle and I spin it around that axis, which is called the axis of revolution, it generates this. And that thing is called a disk. Okay? And I want to be able to find the volume of the disk. The concept of what we're going to do is pretty straightforward. If I find the volume of that disk and then I add up all those disks, I'll get the volume of the figure. You with me? All right, good. First things first, we need to find the area of that rectangle, which you've done already, so it shouldn't be that bad. And that's why, like it says there, that's why the rectangle thing was so important, because we're going to use that rectangle thing over and over again, and it will actually make our lives a lot easier using the rectangles than trying to do some other methods. Okay, so that's our first chunk of information. We want the volume of the disk. If we can find the volume of one disk, we're good to go. And that volume of that disk is found by the area of the disk. Yeah, that's right. Area of the disk, which is also a circle, times the width of that disk. Okay, so you notice pi r squared. Pi r squared is the area of a circle, and then you multiply it by all the number of circles that you have, those infinitely skinny circles, gives you the volume of the disk.
Is it important to capital
Yeah, it will be more important later. So I'm gonna say yes, it's important. So there's a picture of what's going on. I've got this region here. It's a little hard to see, but I got that function f of x going through there in red, and I chose one representative rectangle in yellow. If I calculate the area of that rectangle and then spin it around, I'll get a disk. If I take that disk and I add up all the disks that you generate, eventually I will get something that looks like that. But that's not going to work because that's got a bunch of sharp corners, and I don't want sharp corners. I want it to smooth out. So how do I get it to smooth out? See these corners here? Can you see my original curve, the red thing?
Yeah.
It's got nice smooth curves. So if I spin that around, I'm going to get nice smooth curves. But using this method, I get those sharp corners there. I don't want the sharp corners, I want the smooth curve. So the question is, how do I smooth out the curve? Or how do I smooth out the corners to get the smooth curve? What can I do? Patrick?
Make the rectangle smaller.
Good. Or, instead of making the rectangle smaller, I could, what's the other option? Yeah, no, not make them bigger. Yeah, increase the number of rectangles. The same results. So if I make that really skinny or I increase the number of rectangles, I'll be good to go. We're going to make it real skinny. So again, here it is. It's a little easier to see. I want it to be smoothed out like the blue one, not jagged like the gold one. Okay. And the goal is, again, we're going to use integrals to accumulate all those disks. So if I can find the volume of one of them, I use the integral to add up all those disks. And the end result will be the volume of that fancy schmancy figure. So we did this, maximize the number of disks or minimize the thickness of the disks. So we're going to switch delta x down to dx. So delta x is a measurable amount. It's the change in x. Whereas we go down to dx and it becomes a differential which has no thickness. Really, really skinny. And if it's really, really skinny, how many rectangles do we have? Tons and tons and tons. Okay, now we got a cool demonstration. If this works, let's hope it does. And I'm gonna trust that. Yep, okay. Okay, here we go. Get rid of that. Thank you very much. Disappear now. Thank you. Okay, we're just going to look at the blue guy first. And the only reason it's going horizontally is because it was easier to get everything in one picture. Initially, you're going to do them where they spin vertically. But there's my rectangle. It has a width. It has a height. And when I revolve that thing, I get that disk that we're looking for. Okay? And again, I chose bad colors, so it's a little hard to see. But you can see it's generating that disk. This one we'll get to later. What happens when it's not touching the disk or it's going the wrong way. Okay, the other one I wanted to show you was, I think it's that one. Yeah. Okay. So there's a region now that I want to do, and so I split that region into a bunch of little rectangles, but I've got my representative rectangle in the middle. So if I just start clicking through these things, if I revolve that one rectangle, I get that disk that we're looking for. But what I want to do is I want to see all of them, which will show you all those all those disks. And again, you can see across the top I've got jagged edges where all those disks are. If I change the width of that, or in my program I would actually increase n, which is the number of rectangles, it would start to smooth out until eventually I want n to go to infinity, correct. And then the last one.
Mr. Reedy?
Yeah.
For that last one, that one under the x-axis, wouldn't it usually go outside the boundaries if you did the discs like that?
We don't really have boundaries
Or the,
in that there is no such thing as negative volume for us. Am I answering your question correctly? Yeah, we don't care if it goes above or below the axis.
How do you know whether to revolve it around the x-axis or the y-axis?
The problem will tell you. We're going to start with x-axis, then we'll do y-axis, then we'll do some other line other than the x or y. Yeah, it's going to be fun. It's going to be great. We're not going to do this today, but I will show you while I have this open. What happens if it's not touching the axis of revolution?
It'll be hollow on the inside.
It'll be hollow in the inside, correct. So you get that little, but that's not for today. Okay, we're only going to deal with scenarios where the rectangle is touching the axis of revolution. And by the time we get done with this whole system, I have an algorithmic approach for you, i.e. a couple of questions that you ask yourself to help you remember or figure out what method you should use. Okay. But initially, we're going to do all the same problems, and that is our rectangle is touching the axis of revolution. Okay. So let's get rid of this. And don't save that, and go back to our slideshow. Okay. So we'll start with an example. I'm not expecting you to draw these three-dimensional figures, by the way. Okay. If you're feeling saucy and you want to give it a shot, knock yourself out, but it's not a necessary part of the problem. Okay. What's x squared plus 3 look like? Yeah? Good. Standard parabola shifted up 3. What's a line x equals negative 2 look like? Be more specific.
Vertical line.
Vertical or horizontal?
Vertical.
Vertical.
Yeah,
Add negative 2.
Yeah.
And x equals 2?
Same thing.
Same thing. And then around the x-axis. Okay. A sketch will help you. I already have one. Okay. So there's my sketch. One thing you want to add to your picture is that guy. So you know what your axis of revolution is. I'm going around the x-axis. while we're working through this problem, I'm going to ask you some what seems to be silly questions. Like, for instance, is my representative rectangle touching the axis of revolution? Yes. Good. If it is, we're using the disk method, which makes sense that that's what we would get. And when we spin this thing, you'll get a figure that looks like this. And you don't have to draw the thing on the right, you just have to draw the thing on the left. How are we doing so far? Good? Great. Awesome. Let's move on. Find the area of the rectangle first. Same thing we did in 7.1. Height times width. And what's our width? dx. How tall is that thing? It's x squared plus 3. Because that's a distance from 0 up to the function. Are we good so far? What's the volume of that disk? Well, the volume of the disk is the height of the rectangle squared times pi. So this bit here, the x squared plus 3 is the radius. So then we plug into pi r squared dx, because that's the width of that, and we have the volume of that disk. That's the key to the problem. If you can find that, the rest of it is easy. Question?
So just a quick question, did you just pick a random place to put the rectangle?
Doesn't matter where you put it. As long as you're in the restriction of, what are we doing, -2 to 2, you're good to go.
So the area is your R in the, when you plug it in.
Yes, minus the dx.
Oh, yeah.
Yeah, so the height of the rectangle is the same as r. Because when you spin that rectangle, the radius of the circle you get is the same as the height of your rectangle.
Okay.
Okay?
And then
That's an important point. Everybody follow that? The radius of your disk is the same as the height of your representative rectangle. You got another question?
And then dx is the W, like you said,
That we shrink to 0, because we're going to take a whole bunch of them. And again, if you can get the volume of one disk, you're done, because now all I do is set up an integral. An integral from what to what? -2 to 2. A couple things happened there. First of all, I moved the pi out in front. Why did I move the pi out in front? It's a constant, correct? It doesn't matter. And then I fn into that bad boy. I will tell you on the quiz tomorrow, you're going to have to do antiderivatives. So you'll have to show me the antiderivatives. You can't just fn into everything.
You multiply by pi, right? After you have an answer?
Yes, sir.
Oh,
Yeah. I did the fn in thing, and then when I was done, I multiplied it by pi. Cool. Just took answer times pi, or actually just took times pi. Did it for me. Okay? Who's completely petrified? Anybody completely confused? So you're petrified but not confused.
No.
I can work with that. Okay, so you're good? Awesome. All right, let's move on. What if the rectangle isn't vertical? Okay, what if it's horizontal? It's just like the area. The only thing that changes is now we work in terms of y. And so the width of our rectangle will be the value, the function in terms of y. The thickness of the rectangle will be dy. And everything else happens the same way. It's just going to give you a different shape.
That's if the representative rectangle is horizontal.
You got it. Yeah. And that's something that always happens. If your if your representative rectangle is horizontal, you'll be working in y's. If your representative rectangle is vertical, you'll be working in x's. At least for now. It'll change later just to make things interesting.
Can you say that again?
If your representative rectangle is horizontal, you're working in terms of y. If your representative rectangle is vertical, you're working in terms of x. Probably 75% of the problems that you do will be in terms of x. Okay? Let's try one more just to make sure you got it. And less guidance from me. So draw a sketch. Draw your representative rectangle. You don't have to draw the three-dimensional shape, but if you're feeling giddy, you might try to picture in your brain what that three-dimensional shape looks like. Because it gets really big. I'm not doing it to be a jerk, the numbers get huge. And also, what's the cubic root of 32? What's that? I'm actually trying to help you out with this. Oh, also, one other thing I forgot to mention. With the disk method, your representative rectangle must be perpendicular to the axis of revolution. Okay? So therefore, if we're revolving around the y-axis, this way, will your rectangle be vertical or horizontal? Horizontal, correct. So you're going to be working in terms of y here. Oh yeah, there you go. Still using left or right minus left and top minus bottom. Oh, thank you. Everybody signed up? What do we got? Oh. Sorry. First thing in pink is cookie brownies. It's gonna be a good day. I also got cookies, chocolate chip, napkins. Ready to go, Max? Don't touch the banana.
You're eating your napkins.
Shit brought bananas though.
Oh, forks. I gotta put my glasses on. Chips, tortilla, way to be specific.
I specified.
Just plain, oh, got it.
Yeah.
Okay, got it. That was my next question. What are you gonna do with those chips? But if we got salsa, we're golden. What, are you thinking mild salsa?
I mean, that's agreeable.
Everybody good with mild? I mean, it's safe, because you got a day to go through, especially if you're handing out hugs. Strawberry salsa. Arnie Palmer?
I'm not made of money.
No, I won't do it. He already went out twice.
Donuts?
So what's really crispy?
Watermelon. Is watermelon in season?
We're gonna make it in season.
I'm not arguing with you. That's great. Lemonade, apple pie. All right, this is good. This will work. This will work.
This cutting board.
You set it up yet?
Maggie, what does that say?
I can't eat anything because volleyball put me on a diet, so I'm not bringing anything.
We'll bring something healthy.
I can't eat anything, like literally.
What are you talking about?
Bring something you
It
can.
writes down exactly what I can eat at each time, and this class period doesn't fall at a time where I can eat anything.
Should snack.
You could bring like a
Where do you
Water.
want?
bring water.
Bring water.
Rolling Thunder?
Find a new club.
That's too late for that.
I was sick of this.
That's ridiculous.
Yeah, it's a lot. It's fine though. It makes you a lot better. I did it last year too. It seriously helps.
Let's binge Wednesday, you and me.
My cheat day is Monday.
No.
Change
Let's
it.
make Wednesday your cheat day.
I
Let's
can't
just go,
change it.
let's just
Don't
go.
cheat- don't cheat
freaking-
today.
You
Don't
cheat
tell
today.
him. Don't tell him.
Like you and me, we'll just put two desks together. Go until one of us pukes.
Oh yeah, okay.
I'm serious.
Yeah, like the
I'm
ready.
ready.
I mean, I've got the I've got a qualifier on Sunday, so I
So
can't.
what?
I can't
So
eat before Sunday.
Why? What'll happen?
I'll be crucified by my coach.
How would your coach know?
Yeah.
Yeah, just don't
Wow,
show
you are a victim of
I feel like
brainwashing.
crucifixion is method on
Break out of the bonds. Just say no. I dare you to show up at the qualifier with like a Chipotle burrito. You're still eating it like,
You would kick
We
me off
did?
the team, and then
Let
I
us
have
know.
to explain.
what's that?
You kick me off the team, and then I have to explain to my my college coach why I got kicked off the team. That
Because your
wouldn't be
coach is
fun.
a
I guarantee your college
He's a
coach
bum
won't
because
think
of
that.
the taste of freedom.
Probably.
Just so you can eat it.
Are you ready?
This is right.
I don't want.
Okay, beautiful. Any progress?
No.
Got the graph down. Well, that's a start.
I don't know where we'll find it.
Let's do this from scratch. I could probably click and get the answer, but did that go?
Yes.
Right now it's left.
Okay, good.
So you're gonna make a horizontal rectangle.
Okay, so a fifth power function looks kind of like a third power function, it's just bigger. And we're going to go from y equals 32, which is up here, down to y equals 1, which is down here. And since we're revolving around the y-axis, I got that little fancy schmancy thing there. And we want to be perpendicular to the y-axis. So I want my representative rectangle to look something like that. How we doing so far? Good. You don't have to draw it, but if you wanted to try, you would get a disc that looks something like that. I am a trained professional.
You take an art class?
What's that?
Take an art class management to get qualified for this class?
I got 90.
Okay, I want to find the volume of that disc. So let's do the easy part first. How tall is that disc? dy, very good. What's the radius of that disc? Close, but we can't use x to the fifth.
Isn't it y equals 32?
It's the fifth root of y because we have to work in terms of y. Because our rectangle is for
You just solve for y.
solve for y. Right minus left. The right side is that function, the fifth root of y, minus the left, which is 0. So you probably don't need the minus 0, but I'll throw it in there anyways. That's my radius. Okay, so now calculating the volume of that disk would be the radius squared times pi times the thickness. So we're going to get an integral from what to what? Right minus left.
Why did,
That's a fifth root. I got a little overzealous on the 5, I'm sorry.
Wait, what if it's
Or 1 to 32, yeah. Okay, 1 to 32 of the fifth root of y squared. That's the radius squared. Move the pi out in front times dy.
284.
284.987.
Hey, I got that too.
that's what I got, yeah.
So, 2 ways to solve this. Dante just asked a good question. Are we supposed to know how to solve that? Yes. So if this were a problem where I required the antiderivative, you would need to know that that's the same thing as y to the 2/5 power. Which, you know, you're a big boy, you can handle that. But more than likely you would fn into it and get, what'd you say, Megan?
It was 284.987 or 90.7145.
Give me the multiplied out one. You
24
got something different? Hold on.
Wait,
No.
but I got the
I
same
got-
thing.
I got
You got the
the
same thing. Everybody else
I
got
got
the same thing.
279.
Oh,
You were
Well, you're
Never
right.
mind.
I got 284.
I'm pretty sure mine's right.
I got
mine's right.
284.
That's what I got.
Approximately 284.987.
Are you going through decimal place? Are you going through on this?
Always.
Always through.
Units squared, units cubed, which we don't really care about. Who cares? Okay.
You square that.
You guys had another set of parentheses.
Okay, so question number 1. Is your rectangle touching the axis of revolution? Yes. Is your rectangle perpendicular to the axis of revolution? Yes. Therefore, we're using the disk method. Pi r squared times dx or dy. Now, how are we going to make this more complicated? Not touching would be one way. What shape will you get if you take it off? We talked about that already. If it's not touching the axis of revolution, we'll generate a hole in the middle, which is called a washer. We do that tomorrow. How else can I make it more interesting?
I thought we had a quiz tomorrow.
Sorry, Thursday. My bad.
We have a quiz Thursday.
No, we
No.
tomorrow. And tomorrow.
Quiz tomorrow, party Wednesday, learn the washer stuff on Thursday.
So wash your stuff tomorrow.
I probably not yesterday.
Beautiful. Dante, staying on task, said the other way we could change this is make the rectangle not perpendicular to the axis of revolution, also known as parallel, correct. That's when we get something called shells.
Okay.
That's gonna be fun.
Doesn't sound like it.
Exactly like turtle shells, right.
What is it?
So you have to decide if you want Leonardo, Dante, no, not Dante, Leonardo, Donatello,
Yeah.
Raphael, and Michelangelo.
Can
You gotta pick one.
I mean, I'll take Dante.
Can you do that? Can you match the names with the colors? And the weapons?
Raphael's red, Michelangelo.
With one weapon?
He's got those little like blades.
Size, okay.
Yeah. Michelangelo, is he the purple one?
He's yellow, orange.
No, he's orange.
Orange with.
Donatello.
He's purple.
Purple with the staff. And then Leonardo was the samurai swords.
Cool.
Wait, Mr. Reedy, I'm just confused on where you got R.
What's the matter?
Something's not clicking on how you got R. I know-
R is the radius,
Yeah, but-
which is also the height of the rectangle.
Yeah, but then when you got the fifth root of Y, how did you know that that was the whatchamacallit, the curved line?
Right minus left. If I go all the way to the right side of that rectangle, I'm at the function, fifth root of y. If I go to the left side of that rectangle, I'm at the line 0, so I get the fifth root of y. Okay. The other problem that we can do is take all those weird things that we talked about and now put it over a line that's not the x-axis or the y-axis. I don't know if we're going to do that today. Let's see. No, we're going to stop there. Don't worry about that. Now, you might get to, I didn't go through the homework very carefully. You might get to some wash